Hello and warm welcome to SAP on Azure YouTube podcast, episode 220. Today is December 5th, and today with Holger and Robert, we are here to talk everything and anything related to Microsoft and SAP. Hello. So, one very important, very interesting topic. We were talking a little bit in the past, but we will go now more deeper on a Premium V2 storage. And especially what does it mean for the SAP, where it can be used, some interesting new general availability of feature of conversions from Premium V1 to V2, which is very much asked, and existing customer already asking, and Robert will tell us all about the Premium V2, and Robert is basically, I think it's almost becoming like a part of furniture here, you know. Often, but still, it might be that some guys do not know you, Robert, so feel free to introduce yourself, who you are, and what do you do.
I hope it's not hidden speak. I'm too often. No, hello everybody. My name is Robert. Robert Biro. I'm on Azure engineering team for SAP, based out of Switzerland. And yeah, as happy to start a conversation between us about Premium V2 SSD for SAP.
Yeah, and basically you were doing, in the engineering, a lot of work and testing on a V2 for the SAP in a different context. So tell us a bit.
Indeed, yes. Premium SSD it's a product that has been introduced about 2 years ago on Azure generally. It's generally available for 2 years, roughly 2 years by now. It has been certified for SAP Use for quite a while, and there has been a lot of work behind the covers to get it ready. Get it ready is a wrong word, to get it better, working better and working really, really well for mission critical workloads like SAP. And we have been definitely at that point for quite a while. And that's the reason I would like to speak today and kind of bring a bit of awareness on that topic and the benefits that people have, because I think it's a very exciting product. With that said, I'll straight jump into the presentation. Or do you want to share, Goran, or should I share?
No, you can share. You can share.
Let me then share straight, jump into it. I would like to talk about mostly, first of all, an introduction. Where are we with Premium SSD, Premium SSD V2? What it is, what it does, what are the capabilities of it, what are the potential limitations, or something to keep a mind of or to think about. Where does it fit into the SAP environment on Azure? And obviously, once you are familiar with it, you would want to start using it, I hope. And how do we get there? Mm-hmm. So the Premium I'm going to say now Pv2 as Premium SSD V2, because my tongue will probably break if I have to say it 50 more times in the course of this presentation. Pv2 is not an official name, but let's talk Pv2 and Pv1 as Premium SSD V2 and V1. The main characteristic, as at least I see it, for Pv2 is we don't have any more set disk sizes. So with Pv1, Premium SSD, there were set sizes, 64 gigabyte, 124 gigabytes, and 256. And you deployed those. They had certain characteristics on performance, not with Pv2. With Pv2, you really have three sliders, three tunable parameters. So the disk size, you can go as little as 1 gigabyte all the way to 64 terabyte, and everything in 1 gigabyte increment. You have then the second toggle for the throughput, and the third one for IOPS. All three are completely decoupled. They're completely adjustable separately on its own. There are some, obviously, some technical things that are coupled for very, very small disks, how things grow. But effectively, for SAP workloads, you deploy a disk of a certain size, you get 125 megabytes per second and 3000 IOPS. included as part of the capacity. That's the baseline performance. Mm-hmm. And you can turn those up. If you want more throughput on a 10 gigabyte disk? No problem. You want to have a super high performant 1 terabyte disk with 1.2 gigabytes per second? No problem. Each of these sliders are monetized separately, but it has overall, if you do comparison from the same characteristics, same parameters of a Pv2 disks with a Pv1, you will see that Pv2 is faster. So it's faster, it's more tunable, and it also is faster from a latency perspective. That's also one big aspect. So it has also not just more throughput, it also has a lower latency which does fulfill HANA requirements for productive use, meaning there is no more need for any acceleration, no write accelerator. It also unlocks a few other use cases, which we will talk about in a second.
So when I think if we would a little bit try to compare here some benefits to V1, and let's think about scenario, suddenly you have a burst, you need more performance, more throughput and more IOPS. With PV1, generally you would have a stripe, so you would need to add additional disk, possibly, right, to get more, because each disk has a fixed throughput and IOPS, and
exactly.
That's it, and then you still continue to pay, and here you have just the sliders. You slide more throughput or IOPS during the peak, and then when the peak is gone, then you can downsize the throughput and IOPS, for example, and also pay as you go, right?
Exactly. The size is expandable. It's explicitly
in one
said
direction.
expandable, not redundant. Yeah, one direction. Well said.
Size, only
it only
size,
go
but
up.
throughput.
It's just the way it is in a public cloud for protecting the customer data. But like you said, if you want to have 100 gigabyte disk with 1 gigabyte per second and only for 4 hours in the night, no problem. You can do it, and then you update the disk properties to go back to the baseline, for example.
Yeah.
And only for those 4 hours, you pay more.
That's actually pretty cool. But to be honest, for me, simply the fact that I can have a small disk with higher throughput and IOPS is already a huge win, because I still remember like 7 years ago or something like that, when I started with the whole SAP on Azure stuff, we were spending so much time to figuring out what's the right stripe set to get to the required throughput and stuff like that. And there were cases where we had to add much more storage than what's actually required from a storage perspective, simply because we needed more throughput. And here now I could have a very small disk, and even if it's dynamic, it's even better than maybe I have my small disk, maybe I already have some good throughput that is good enough for I don't know, maybe the application server needs a little more or whatever. And then I can even scale it up through the night, like what you just said. That's actually pretty cool.
Precisely. I like the non-binary sizes. Like you said in the past, 64, 128, 256, 1024, no more. You want 600, you pay 600. You pay what you want. It's a really beautiful, cool. The scalability is very nice. So let's talk a little bit on the details. How does it, and what do we have to think about when we deploy that? Now, first of all, and as always with YouTube videos, it's as of time of the recording. Things change, things always get better. So if anybody watches this later on, things probably have changed, or most certainly have changed. And some of these, the points mentioned here are gone. But as of today, the VM needs to be zonal. That means Pv2 can only be attached to VMs which are either single zonal, so a separate, just a VM as zonal defined, or it's part of a VMSS flex, a scale set, which is zonal. There is no, right now, today, support for AV set VMs or simple regional VMs, so VMs which are just deployed in a region. There's definitely work going on that, but as of today, this is where we are, zonal only. The second part that people need to really think about Pv2 is where is it available? Now, we do have it pretty much in the most important regions or the regions where we would see SAP deployments. Not everything, but it's, as of today, it's vast majority would have Pv2 available for people to go ahead and start using them today. Keywords, start using them today. There's one thing that people might not be aware of, and especially for a larger customer, something to really keep in mind. There is a quota, like we have on the CPU side of things, on the vCPU side of things. There is also a Premium V2 quotas for how many disks and what the size is. It's size limited. There, I put on the screen on the slide what are the current default limits, which again might change over time. For some customers might say something else. Go ahead and look at your quotas for Premium V2, so you don't want to run into problems eventually. A little anecdote, Premium version 1 also had a quota, which probably most people are never aware of, but it did exist in the past. Still does.
I'm the one, never had problem with quota of V1, but I faced with V2 rarely, but still happens.
Exactly. Yeah. Second thing to look about or think about the deploying Pv2, there is definitely some feature gaps still as of today. The gap is definitely shrinking as we go, and very, very rapidly. The teams are good, really working very, very good on this, and huge improvements are coming as well. Right now, there's no OS disks. So if you look at the list of limitations or things to consider, OS disks are currently Premium SSD V1 only, no V2. Not a big deal, it's just the way it is right now, no OS disk support. In terms of backups, and some customers might be using disk snapshots or tooling which uses or relies on disk snapshots. For PV1, the snapshots are instantaneous. They are executed immediately, and you can restore that snapshot immediately. For Pv2, it is today not instantaneous, so you do have to wait until the background copy process completes before you can restore. Now, the backup is complete once you start the snapshot. It's just a under the hood copy of data, which takes some time because you can't restore until the copy is complete. It's important to point out for some backup scenarios. There's a little bit of a gap on the Azure Site Recovery, and also thinking about the Azure Site Recovery, does this DR region have Pv2 available? Because it's a source and target would need to have the same storage size. Probably this is just as of today, very likely, very, very soon. Most of these limitations will go away, just something to keep in mind. And do look at the documentation, what it is today, what are the limitations, if there are any. The next point is, it's not a limitation, it's something to keep in mind of, is the host caching. And by host, we mean the virtual machine here. For Premium V1, we have several caching modes. We have a read-only mode where the reads are cached. So-called read cache. We have the write accelerator, which is used for the database log disks, where the writes are cached into a very specific write accelerator on the M-series hardware. Now, Pv2 has no caching by design. By the way, similarly for ultra disks are next tier in storage. There is one thing that we will talk about in a little bit detail later on, is there might be some situations where customers need to tune dynamically the IOPS and the throughput. Mostly on the IOPS side, there might be for databases like Oracle and DB2 a requirement to increase the IOPS. We'll talk about it a little bit, just really the takeaway. Caching is not there, caching type is none, and this is the way it is today.
I mean, basically, write accelerator on PV1 is to get sub-millisecond latency needed, for example, for the HANA or any database. But actually, with the PV2, we already have a sub-millisecond latency, so we could say it's not needed in some way.
Exactly. Very, thanks for reminding me, Koran. Yes, indeed. That's the design consideration for Pv2. Pv2 has a sub-millisecond latency for reads and writes. So we don't need a write accelerator to fulfill the HANA requirements. Where are we on the SAP side for Pv2? So we are good to go. I kind of look at it as three different areas. The small VMs, smaller VMs, application servers, infrastructure VMs, central services, what have you, basically non-database VMs. Good to go. HANA, absolutely no concern. HANA generally doesn't anyway benefit much from any read caching. So since anyway everything has to be in memory, what is being accessed. So from HANA side, absolutely nothing to really think about. On the non-HANA side, green check mark. It's fine. It's productively released. It's available for use for co-production. However, for especially very large environments, many terabyte large databases, there might need to be an extra effort involved for anybody deploying Pv2 or changing from Pv1 to Pv2. And the point is caching. Where are we on the caching side? Are we using cache? And I'll talk a little bit more in a next slide on that. So I'll jump straight ahead on these three scenarios, just in more in details. The small VMs, the non-database VMs. Nothing to consider really other than you get a lot more throughput and IOPS from the Pv2 storage stack. So previously, these VMs had a P6, a 64 gigabyte, 128 gigabyte with some bursting and so on. With Pv2, you get a lot more, especially if you have an application VM that you attach a lot of disks to. Every disk, every Pv2 has a baseline of 125 megabytes per second. You might hit the VM limit. Is it a bad thing? No, really. It's just something to be aware of, that maybe the VM will be holding you back and not the disk potentially. And just again, like with the caching, Pv2 has no bursting. So with Pv1, we have disk bursting for the very small disks, and also VM bursting, where a VM can temporarily get more I/O performance. With Pv2, we stick to the limits. We do have a higher baseline, and we don't see a need, or that's the design. There is no bursting on the disk level. If you need more performance, it's perfectly tunable.
Yeah.
Looking at the HANA VMs. HANA VMs, there's a few points to really think about. And first point is, I have a disk with Pv2 which can go to many, many terabytes. I can set it to 1,200 megabytes per second throughput. Do I still need to stripe? Yes and no. It's a customer choice. You really don't need to. Your point, Holger, from how we really have been thinking in the past, always many, many disks we must. With Pv2, we really don't need to. However, it's still a good practice. It's still good practice. The aspect is you get a lot of stuff for free. You get each disk has 125 gigabytes. Right. Yeah, so why not take two of those and get 250? I'll speak on that point a little bit later. But yeah, the decision, do I stripe or do I do a single disk? Secondly, it is all documented. We have a documentation for disk sizing, IOPS, and throughput for every database, although this is for HANA specific, so this is here. The one thing that people really need to think about is the right sizing. No more fixed sizes. Do I need 2 terabyte HANA data, or am I good with 1.2 terabyte and pay less? You choose. You have the option now. That's really good argument to right size when you deploy Pv2. You can go on a granularity of 1 gigabyte. You choose. Write accelerator we mentioned. There is no need for a write accelerator. It doesn't exist with Pv2, and we don't require it for HANA data, for HANA log, for the log writes. There's no need. All writes are expected to complete under 1 millisecond. And the one last point, really the comparison of performance. It's something that I definitely expect the community to compare. It's a natural thing, PV1 to PV2, or especially PV1 with write accelerator versus PV2. Now, probably PV2 will be on a couple of 0 point something milliseconds slower. Does it make an impact? And this is really an important thing, is not to compare some dashboards and synthetic write speeds. Those are important points and important factors to think about. But really the bottom line is the application performance. We are seeing very, very large environments and very, very large systems which are working perfectly with PV2. So even though on some there might be a slight, I don't want to put any numbers, but the slight difference between PV1 and write accelerator to PV2. The important part is, how does the application behave?
Yeah, I would guess that here HANA would also benefit for the HANA data disk from the write latency, because with PV1 it's single digit. With PV2 you are in sub-millisecond latency. So, and that would generally also overall positively influence the overall HANA and SAP system on HANA performance.
Exactly. Thinking of the save point saves.
Exactly. Yeah.
Merge log information, and so on. Definitely a benefit here.
Yeah, and I think I don't know how their default is, maybe it's 5 minutes. I don't remember on the HANA, but they would flash it to the data disk, and depends on the number of changes, definitely would happen much faster.
Absolutely.
Yeah.
Speaking on HANA, it is all the SAP stack is fully certified for production. Just a quick screenshot of the production for the documentation where it's hiding. So on the do I have a pointer? No, but on the right side with the Premium SSD for V2, we have right side here. There's a separate documentation for HANA, the details. And if you are looking at the SAP certification and on the HANA certified directory, now for each VM there is some text below the information with the options for the performance. Pv2, Premium SSD V2, is mentioned here, along with Pv1, Pv2 with write accelerator, Ultra Disk, and Azure NetApp files. And that's one very, very good aspect for Pv2. We have E-Series. Yeah. We have now E-Series support because E-Series never had write accelerator. Write accelerator was reserved for M-Series and still is. Yeah. For E-Series, we don't need a write accelerator. So now E-Series have been HANA certified for a long time. Mm-hmm. Now, however, with Pv2, the door is really open for super easy adoption across the whole stack. And it also does make financial benefit. When you compare the very small sizes, M-Series with E-Series, probably the VM part, the compute part, would be cheaper. Yeah. For the audience to test and compare. But you don't just save on the storage side of things. You would also see a saving on the compute side if you use E-Series here. Yeah. And this is only going to get more important in the future.
Mm-hmm. So basically, yes, but they could still run on M-Series with V2 if they want. I mean, if exactly. There's a specific, so much more flexibility on a SKU size. Nice.
Exactly. You get the E-Series 128 if you want something very small, 160, 256 gigabytes, 512, and so on. So you have a lot more granular memory sizes available to you, which in even M-Series did never covered. That's for HANA. How does things look on the non-HANA database side? So for the typical Oracle DB2, the ASC, MaxDB environments, Now the stripe and non-stripe, that's still obviously a customer choice, and it still makes sense to stripe. So it is a good practice. We are really thinking of this is full customer choice. See what you need. The one thing is I didn't mention earlier is the future. So even if you go with a single disk, the limit for Pv2 today is 1,200 megabytes per second. But a lot of the VMs today allow a lot more throughput. So you would be potentially limiting yourself if you have just one disk. Whereas with multiple disks, it's a multiplier. So we have VMs with 8 gigabytes per second storage throughput, and you can bet the future is going to be only faster. Same thing.
And plus financial benefits, I mean, free number 125 megabytes and 3,000 IOPS per disk for free.
Exactly. It's beautiful. Yep. It's fully documented, so all the SAP databases have a Pv2 section in their documentation. There is one thing that's a bit more technical. The Premium V2 SSD allows 2 different logical sector sizes. It allows the natively or the default section is 4K, but it also supports 512 bytes emulated sector size. This is important to think about in the context of DB2 especially, but also some older Oracle versions if you're using, because for DB2 we do recommend to use 512 sector size, which is a setting on Pv2. On Pv1 you could not set this. With Pv2 you have these options. And some Oracle versions, I think it is Oracle 12 release 1, which was, or basically an older version, which did require 512. The documentation has these details. Something to really think about, something which was never an option with Pv1. Right sizing is, I think, even more important or a bigger thing here. With you have a lot more file systems, you have a lot more, at least on the LVM side of things, a lot more disks to work with. Pv2 gives you a lot more and easier tools, again, with the 3 sliders, with the 3 options, how much capacity, and you can really right size on these databases. And the last point is, especially here, not so much on the HANA side, but on the DB2 Oracle side, the read caching. You no longer have a read caching for very, very large databases, especially. Really think about and compare how much impact it has. The one thing that I really would first, did I really use read caching at all in the past? It might have been running Pv1 with no caching enabled. So first of all, I check, have I enabled a read caching in the past at all? Was it enabled in the past? And if it was enabled, Azure gives me, both on the VM side, on an individual disk level as well, how much caching has been used in the past. So build a dashboard with all the disks present, all the VM details, and look back. Look at some peak application performance in the past, how much caching has been used, how much caching has been consumed, and run the data.
Because you're basically saying most likely this wasn't so crucial, the read caching.
It's completely individual. It's completely individual and impossible. That's why I'm quite careful here, as in people should really think about the caching.
Okay. Yeah. Okay. Yeah. And then if they see, sorry, Robert. And if they see that caching is really crucial for them, then most likely they would stick with Pv1.
Great point, Holger. What if thanks for bringing this up. What if I come to the conclusion read caching makes a big difference for me? Pv1 is not going away.
Yeah,
Azure is heavily dependent on this. This is in no way any sort of everything's moving. No, this is just another tool in the toolbox, which makes sense, but maybe in some cases PV1 makes perfect sense with caching. Ultra disk might make sense because I need even lower latency or even more higher throughput. Azure NetApp files might make perfect sense. So this is just another arrow in the quiver. Use what's right.
Yeah.
Thanks for bringing it up. Yeah, indeed. On the point of the striping and non-striping, let's have an example. Goran, you already touched upon that. So I get stuff for free. Great. I have Pv2 has 3 price elements: the capacity, how much I'm consuming, how much throughput over the 125 in addition. So that's monetized. The 125 is included, and how many IOPS over the 3000. So if we take one example, a 1 terabyte HANA data, I require 1 terabyte capacity, 600 megabytes throughput, and 5,000 IOPS. That's our baseline recommendation to have. Now I can go with a single disk, perfectly fine. Capacity, I have 125 already, so I need 475 additionally. So that's the second toggle, that's the second price. And a 2,000 IOPS, because I need 5,000 total, 3,000 I have, I need to add 2,000 extra. I end up with the price here. At the end, 1 terabyte, 600 megabytes per second, 5,000 IOPS for a certain price, single disk. If I go with the second option, 4 disks, and I do a strap set, so 4 times quarter terabyte to get my terabyte of capacity, 125 each disk has, so that's 500, 125 times 5. I need 25 on each of the 4 disks to reach 600, so plus 25 additional throughput. The IOPS I can leave as is because I have 4 disks with 3,000. I end up with 12,000. So my second option, I have the same capacity, I have the same throughput, I have double the IOPS included, and I pay less.
Yeah.
So I think it's a nice case that striping does make sense. And the second benefit, if I ever have an upsize in the future of the VM, it's far easier to scale 4 disks than to scale 1 disk. However, there is one thing that really to not take this overboard and not make stripes with 20 disks because something is baseline. So we do have a recommendation of do not go beyond 4 disks for database data, 8 for the very large databases. There can be exceptions, but that's the best practice and the reasonable number. Anything beyond can be detrimental unless it's some really, really large database. And similarly for database logs. So 2 is a good number to start with if you want to go striping. But like I said, it's the customer choice. If you want to have a single disk for simplicity of use, you have the option.
Yeah, that's great.
Yeah. So now customer has an PV1, and he wants to migrate to PV2.
Goran, are your scripts ready? Not yet.
Yes, I'm peeking into your PowerPoint.
We will talk about it in the future, I think. How do I get there, really? Now, first of all, it's a new deployment. So you can think of a new VM, especially if you have some sort of automation with SAP deployment framework, for example. You move the application from the old VM to the new VM. New deployment, so from scratch. Check that the region has it, that you have a zonal deployment, that you have a quota, or if it's a large deployment, and so on. On the second part, for the existing, there is our need for downtime in here, since we are changing the storage. Now, one way is you attach new disks. So you take new set of new Pv2 disks, you stop the SAP environment, you copy the data, and you throw away the PV1 because you already have the Pv2. Now you copy the stuff with file system dump tools, XFS dump, or whatever copy tool you want to on Windows as well. You recreate the new stripe set. If it's multiple disks, copy the data. We'll talk about a little bit more detail on this scenario. The second scenario, or second and third really, but I consider them the same because it's really the same behavior for both. Convert the disk feature. So convert disk has been made available, I think, a few weeks back. It's now generally available. It means what you are accustomed to. You go stop the VM, go to the portal, change the disk from Pv1 to Pv2. If the prerequisites are fulfilled, that it's in a supported region, it's a zonal object, and so on, you will have the option to change from Pv1 to Pv2, or from standard SSD, standard HDD to Pv2. This is made available. Secondly, you can just create new disks from snapshots. Mm-hmm. So in context of Pv2, both these, so point B2 and B3, both of them are a background copy. So that means you can start using the disks immediately. So you can start the conversion of the disk, change the disk type. It does a background copy under the hood, but you can attach the disk, you can start working on it, you can start the VM. Same thing with if you create a disk from a snapshot. It's also in the documentation highlighted in more detail. Keep in mind it might have some reduced performance while the background copy is performing. Shouldn't have really any major impact on HANA workloads. For Oracle, DB2, and the non-HANA databases, there might be some noticeable impact because the reads are slowed. Again, documentation has an update. There's a lot of work going on here. Things might change in the near future. If we talk about on the first point, the new disks, new disks, so you can attach the new disks. The reason I like the new disks approach, or it's something to really think about, when you attach the new disks and not convert the existing ones, it allows you to right size. So you might have had a certain standard some time ago. This way you can use smaller ones. You don't need the big setup. Yeah. Or you had some design that you have been using in the past, I don't know, 2 disks, and now you want to go to 4 disks or single disks. Yeah. Now you can change it. If you do the conversion route, you can't, because you are taking what you have to what you do. Yeah. What you just changing the disk size. So that's one thing to have. Yeah. On the change SKU and the snapshot approach, I just want to really talk about a little bit that the size stays the same. You are not reducing the size of the disk. You can always increase, of course, but the size remains the same, meaning also if you had a stripe set of X amount of disks, the X amount stays. You can't change your design. It is a background operation, as mentioned. The one thing to think about is the adjustment of the IOPS in this scenario. Typically, the new Pv2 disinherits the values of the Pv1 in terms of throughput, in terms of IOPS, and so on. You have 4 changes in a 24-hour rolling window, so you can dynamically adapt them if you want more, if you want less, up to the baseline or down to the baseline, or all the way up to the limits. We talked a little bit already on the sectors, so I'm not going to delve too much into that. Look into the documentation if you want to, how logical sectors are necessary for some workloads, such as DB2. If you're going from Pv1 or from standard SSD to Pv2, it will be a 512 disk. And if you create a new Pv2, by default, it's a 4K. From a performance standpoint, not much to be concerned about. It's more of a usability case in some of the databases.
So basically, if customer with Oracle or DB2 are converting from Pv1 to Pv2, they will land still with 512 because the Pv1. However, if they create a new disk, then they have to specify that they are created with 512 sector size and not the default of 4K. Right?
Exactly, Coran. Excuse me. And that's really something to also keep an eye on the documentation for any updates, for any changes. So if at least I wrap up, I'm sure you will have maybe some points. It's good to go. Pv2 is good to go. It's productively certified for all SAP workloads in Azure. Think of the 3 parameters, the 3 toggles, the 3 switches that you can independently adjust. Do I want to stripe or do I not want to stripe? It's a depending on the question you ask and on the scenario, one or the other might make sense, and the whole cost calculation. Is it cheaper? Can I go reduce the size? Can I go to using E-series for small HANA databases and so on? A lot of elements, a lot of things to play with. It really gives a different some elements to think about and to calculate with for people.
Right.
So,
maybe one quick question, also as a summary, or to also get your feedback there. So it sounded like the way to go to Pv2, you would actually recommend, if possible, to go with the new disk approach, because there you have basically the opportunity to have a fresh start, to right size really the setup, avoid maybe or correct some design errors that you had done in the past, but it takes slightly longer than when I can really use the change or the snapshot approach, where I can basically do this in the background and so on. Is that a fair statement?
It's a fair statement, Holger, and it really depends. If I'm a customer who is very, very much into very strong on automation and moving workloads from one version of the infrastructure to another, probably a new deployment is super quick as well. Which uses exactly the same benefits as you mentioned. But yes, for larger VMs, HANA database VMs, the approach with new disk really gives me a clean slate and the biggest cost saving. On the other hand, for smaller VMs, application VMs, probably the disk conversion is very appealing. So it really depends.
Maybe just a little bit to differ between convert disk and create Pv2 from Pv1 snapshot. Convert disk, meaning in the past we could convert the disk from Pv1 to HDD or SDD and then backwards. You just change it, the type. VM has to be stopped or disk has to be detached, and then you can change. But basically you can do with the convert disk the same. So just change from Pv1 to Pv2, but the VM has to be zonal. Disk has to be zonal, right? That was one prerequisite, so to say. Correct. So where would then the snapshot play the role? I mean, the third option, when we talk, you create a snapshot and then from snapshot create a disk.
So the snapshot first of all, until a month ago, we only had the snapshot way. The conversion only came relatively recent. But the snapshot is definitely giving a lot more options to the customer and different scenarios. For example, say on a backup, on a restoration, for example, you could use the snapshot. On drawing a bit of a blank right now for more scenarios, even though we talked about it an hour ago, Goran, just on this topic.
If you would convert the VMs from regional to zonal one, you have to use a snapshot, because from snapshot you can only then recreate a new disk. So as a zonal disk, which would be then a Pv2, right?
That's correct. Yes. Yes.
Or if you would choose maybe to switch, if you switch from one zone to another one and then still also switch to Pv2, yes, it's still the snapshot has to be
changing
used.
zones, yes, for example, too, yes.
Yeah. But actually convert disk, it's very convenient. Assumption is It's a VM zonal one. It's very, what Holger mentioned, it is very easy to do it. It's really, I mean, yes, it's maybe it's not an ideal from a redesign perspective, or might not be ideal, but it's from a operational perspective, it's very easy.
Yeah.
Indeed.
Nice.
Excellent. I mean, we covered really. I also got some. I mean, there are a lot of updates from the last time we were talking about the Pv2. Honestly, really, I think the documentation was tuned quite a bit. The recommendation, this ability of conversion is really, I mean, quite new, brand new, as you mentioned a few weeks back. And why to do it? I mean, I think it was not clear in the past. Now we just kind of, you brought an excellent perspective there, when and how to decide it, right? So super overview. I mean, Robert, thank you. I mean, as the thing in clouds are always changing, I mean, I'm pretty sure we will see you definitely back again.
Thank you for having me. It was a pleasure. And yes, there will be a blog post on the topic. Once it's available, I will. We will put it into the comments probably as well.
Super, definitely. And you can embed in the blog as well the video. So
good point.
Yeah,
indeed.
Yeah. So support each other, right? All right. Thank you, guys.
Thank you,
everybody. Thank you, Robert. So I'll definitely see you here. And I mean, the community is definitely encouraged to put any kind of question or request in the chat. So we will surely address it.
Great.
Thank you, guys.
Thank you, everyone.
Thank you.
Bye-bye.